All right, so we're going to be talking about inequalities. And the nice thing about inequalities is that for the most part, these things are going to look almost exactly like equations, at least when we're solving them. But just to start with, let's talk about what some of the basics of our inequalities are. We've got things like greater than, and if I've got something greater than, it's usually helpful to put together a quick number line. 1, 2, 3, there's my 3. And it's anything that is greater than and anything that's bigger than this 3 that actually satisfies this inequality. Well, I could also have less than. So let's say I've got x is less than, I'll do a 2. 0, 1, 2. So here's that 2 again. And here, anything that is smaller than this 2. Now, you'll probably notice that I'm using an open circle here. We use an open circle to say that it cannot equal. Just like if I were to graph something like x were equal to 2, I would just put a dot on the number line. Here, I put an open circle saying, that actually cannot equal this. But this is less than, or lesser than. Well, I could also do something like greater than or equal to. So I could have x is greater than or equal to, I'll do a -1 this time. So, and there's a couple different ways I could actually state this other than just greater than or equal to. So here's this -1, 2, 3, 4, 0, 2, 3. But because it could equal, I'm going to put a closed dot or a filled in circle there, and it's anything larger. So anything to the right on our number line, I shade in. So this is greater than or equal to. Or another way of saying this is no less than. Or you could also say, or no less than, or another way of saying this is at least. So I could say this is at least -1. So these are all words, these are things that you could see in a story problem. Very similarly, I've got let's do x is less than or equal to, and I'll do a 3 this time. There's my 0, 1, 2, 3. There's that 3. 4, 2, -1, -2, -3. But because it could equal this, it could equal that 3. I'm going to have a solid circle here. And because it's less than, everything smaller, so everything to the left on the number line is going to be shaded in. So this is less than or equal to. You could also say this is no more than 3. Or you could also say that this is at most 3. So these are some equivalent phrases. Now, this is just what things are going to look like on a number line. And we're also trying to give you as much of the lingo to do this. Nice thing with this is this tends to make some good intuitive sense with a lot of folks, simply because we tend to think of things as in ranges, as like, oh, this is bigger than this or smaller than that. Now, the rest of the things with inequalities that are important to keep in mind are that if you're solving an inequality, you're going to solve an inequality just like an equation, with one important exception. So if you're solving an inequality, you're going to solve like an equation, but you're also going to, the only time that things are going to change are if you multiply or divide by a negative. So it's multiply or divide by a negative, then you're going to flip the direction of the inequality. So for example, I'm gonna do a couple, 3, 4 examples here really quickly. Say I've got like x plus 3 is greater than or equal to a 7. I could subtract 4 from both sides, and because I'm adding a negative, nothing is going to happen to the direction of that inequality. This is just going to be, x is greater than or equal to, it looks like a 3. Oh, whoops, sorry. I got excited. I was thinking ahead, too far ahead. This is actually greater than or equal to a 4. My apologies. I sometimes think too fast. Yeah, so I'm subtracting 3 from both sides, not subtracting 4. I could take both sides of an inequality. Say I've got something like x, I could have a 2x is less than a negative 18. Here I can divide both sides of my equation, and as long as I'm dividing by a positive number, again, the direction of this inequality stays the same. So this is going to be just x is equal to negative, or actually is less than negative 9. It is only when I do something like, say I've got negative 4x is greater than or equal to, say, 32. It's only when I divide by a negative number. So if I'm taking both sides of this and I divide by a negative 4, that's when the direction of this inequality is going to change. So this is going to be x is less than or equal to negative 8. It doesn't matter the side of what I'm dividing. I have to be dividing by a negative number for me to flip the direction of this inequality. Otherwise, solving inequalities are, as you can see, this is just like solving an equation. I could do something like, I could have, negative 7 is less than 2x plus 9. And from here I could say subtract 9. So I've got negative 16 is less than my 2x. And I would divide both sides by 2. That's a 2. I realize that I have kind of chicken scratch writing sometimes. So I would have negative 8 is less than my x. So we're solving these just like we would any other equation. The only exception came when we had to divide by a negative number.